Last one for the night. Then I gotta go to bed because darn, you're keeping me up late tonight. Okay. This is section 9.4. It's about inscribed angles, and now we're starting to get quite a bit of information about circles and the angles inside the circle, tangent lines, etc., etc. And they're going to start heaping all this stuff together if they haven't already started it quite a bit, and you're going to start adding numbers to it, and it's going to become a little bit more than just definitions. But we still have some definitions to go. So inscribed angles are angles that have their vertex on the circle. So angle B is considered to be an inscribed angle because the vertex is on the circle. Now that you know what an inscribed angle is, the measure of the inscribed angle, we'll call it, I don't know, it looks like it could be about 40 degrees, is half the measure of the intercepted arc. This inscribed angle goes out to this arc, which means that my arc, since the measure of angle B is equal to 40 degrees, the measure of my arc AC is going to equal 80 degrees. Because it's an inscribed angle, this is half of that. So if I were to actually have a central angle here, it would be 80 degrees because that's what this measures. But when you make it an inscribed angle and not a central angle, it cuts that in half because it has to go twice the distance to get to that vertex now. So you have to kind of keep these things in mind as you're going along. Now, they're not going to tell you that this is 80 degrees. That might have been a problem for you. If they tell you this is 40 degrees and they want to know what the central angle is, you'd have to go from the 40 degrees to this must be twice that, which is 80 degrees. It says this is its central angle, that makes your degree there 80 degrees. So they're kind of going to build stuff together around things like that. So that one's a pretty big one. And then down here, we have ABD in purple and ACD in pink. Since they intercept the exact same arc, AD, because they both go to AD, C goes to AD and B goes to AD. Since they intercept the exact same arc, that means that these two angles have to be the exact same measure. Now, it might not look like it because they come at it a different way, and this side is different from that side. But when you sit there and measure them with a protractor, you get the exact same measure every time. Frustrating, but true. So if I were to know that arc AD was, say, I don't know, 120 degrees, then we would know automatically that angle B and angle C are both 60 degrees, because you would take half of that 120 to get 60. Since they are congruent, we know if one of them is 60, then the other one has to be 60. That's the thing, they're going to be congruent. Okay. Now, those are the three major big points, but there are a couple of other little interesting points they get from their corollaries. One of their corollaries was the bottom one, down there, about inscribed angles of a circle intercept the same arc or congruent arcs, then the angles are congruent. If a quadrilateral is inscribed in a circle, then its opposite angles are supplementary. Now here, the quadrilateral I want to deal with is AB, quadrilateral ABDC. I want to talk about that one. Then that means that angles A and angle D are supplementary. and that angle C and angle B are supplementary. I don't know what angle A is, but the measure of angle A plus the measure of angle D, by definition is supplementary, has to equal 180 degrees. And the same way with the measure of angle C and the measure of angle B has to equal 180 degrees. That's what supplementary means, that they add up to 180 degrees. And so that's what you have to kind of go with. Help you out a tad. That's corollary 2. Corollary 3 says if an inscribed angle intercepts a semicircle, then the angle is a right angle. So now we're talking about angle E. Since angle E is an inscribed angle because the vertex is on my circle, and it intercepts a semicircle, and we know it's a semicircle because the diameter goes through it. So that means that the measure, first of all, of CDA is equal to 180 degrees. That's what a semicircle would be. Then that means that the measure of angle CEA, to point out that we're talking about, they have the same endpoints as our semicircle does. That means the measure of angle CEA would be half of whatever that arc is, which we know is going to be 90 degrees, which is what they were saying. If it intercepts an arc that is a semicircle, then it's going to be 90 degrees. And then the last one says if two arcs of a semicircle are included between parallel segments, then the arcs are congruent. So now we're looking at EC and AB because they're parallel. So since EC, line segment EC, is parallel to line segment AB, then arcs EA, because that's what's in between the two, has to be congruent to arcs CB, because that's what's in between the two over here. That's all that one's saying. The pieces in between are going to be congruent. Okay, with that information, that should be enough for you to run through these 6 problems. 6. I'm telling you, I'm making it really easy on the homework so that you can go ahead and get them done in the same day you're watching the video. I'm working hard here. I'm just saying, working hard. Working hard. On page 371. The classwork is numbers 2, 12, and 16. And the homework is numbers 4, 14, and 18. That's it. Have a great weekend. Don't do anything to get you in trouble. I'll talk to you later. Love you. Bye.